Hey HVAC pros, ever wondered why understanding heat transfer is crucial to diagnosing and optimizing HVAC systems? Whether you're prepping for certification or just want to level up your game, today's video breaks down the three types of heat transfer: conduction, convection, and radiation with real HVAC examples. Welcome back to SR HVAC. Let's jump in. What is heat transfer? Heat transfer is the movement of thermal energy from one object or substance to another. In HVAC, it's how we move heat into, out of, or around a space. Think furnaces, condensers, evaporators, and ducts. To control comfort and efficiency, we need to understand how heat moves. There are three main types of heat transfer: conduction, convection, and radiation. Let's break each one down. Conduction. First up, conduction. This is heat transfer through solid materials from molecule to molecule. You see this in refrigerant lines, compressor components, and even in ductwork that's not insulated. Example, when a hot copper pipe from the condenser comes into contact with a bracket, heat will transfer to that bracket. That's conduction. Why it matters in HVAC? Insulating refrigerant lines is vital to reduce unwanted conduction losses or gains. And when diagnosing overheating components, conduction plays a big role. Convection. Next is convection, the transfer of heat through fluids or gases like air or refrigerant. It happens due to movement. Warm fluids rise, cool fluids sink. Example in HVAC. In a forced air furnace, the heat exchanger warms the air and then a blower pushes that warm air into the duct system. That's convection in action. Why it's critical? Airflow issues, that's often a convection problem. Blocked vents, dirty filters, or undersized ductwork can all restrict convection. Radiation. Finally, we have radiation, heat transfer through electromagnetic waves. It doesn't need a medium. Heat travels even through a vacuum. Real world HVAC example. Ever stood near a radiant floor heating system or an infrared heater? You feel the warmth even without air movement. That's radiation. Why it matters? In buildings with large glass windows or uninsulated roofs, radiant heat gain can drastically affect indoor temperatures and HVAC loads. How these work together in HVAC systems? In real HVAC systems, all three types of heat transfer usually work together. Example, in an air conditioning system, the condenser coil uses conduction to transfer heat from refrigerant to the coil fins. The fan uses convection to move air over the coil, and the sun beating on the outside unit adds radiant heat. Knowing which form of heat transfer is happening helps you troubleshoot more accurately and design more efficient systems. Here are common mistakes techs make when it comes to heat transfer. Skipping insulation on refrigerant lines. Conduction loss, ignoring poor airflow, convection problems, not factoring radiant heat load in attic systems. Quick self-test. What kind of heat transfer happens? In a duct blowing cool air, convection. Between a warm compressor and a mounting bracket, conduction. From the sun onto a rooftop AC unit, radiation. Understanding these isn't just about passing tests, it's about diagnosing faster, saving energy, and serving customers better. Thanks for watching. If this helped sharpen your HVAC skills, give us a like and hit subscribe for more pro-level HVAC training. Drop a comment below. Stay cool, stay sharp, and keep learning.